make sure I turn recording on. Sorry, ask that question again, Brad. Is there a Lambda?
Yeah, for Docker file. I mean, for Docker shell. I'm sorry, I'm still sleepy. Stayed up late last night.
Anonymous function?
No, just to be able to condense commands. Like, do they have like something that maps commands to smaller? Yeah, that squashes the commands to just like one character, and then you could like write everything really long.
Well, let me see if this like might take you in the right direction. So let's go take a look at like just in general like a random Docker file. So like if we were to go look at Alpine, for example, and look at the Docker file here, notice how all of this is kind of anded together. See these and signs, right? It's APK upgrade, and I want you to run this, and I want you to do this, and I want you to do this, and I want you to do this. That runs it all on one line. If you're asking if there's a way or if there's like techniques to like squash an image, there is, right? There are like techniques to squash an image. But mainly the main focus is running on the slimmest Docker file possible, right? That's typically what the focus is that just make sure your Docker file is as slim as it possibly can be, right? And so that's why you'll see like in some of the links that I posted yesterday is that, you want to slim it out, but there is a Docker squash utility that will actually condense like layers together. So, let's see, I think I have.
Is that just somebody's third-party tool that they created, or?
Oh, very, very much so. Yeah.
Okay, I would think that one's like written in Go or something. Yeah.
Well, and it'll run on any operating system because Go is right. Yeah.
Right.
So, but yeah, let's see. I'm trying to think of where is Docker Squash. Anyway, it's probably out there. But like this is mainly Brad, how they like condense it is you'll see them just run commands as one long line, basically with ands in between. And so you'll see them do that throughout a variety of different files. So if we go back and look at this guy's other files, oops. Let's see if he has an Ubuntu one, for example, which he might not because he probably looks like he just sticks with Alpine. Let's look at uncloud. Uncloud's fun. So look at this. He's again an APK, right? Has a start like doing an update, but then notice he's got like everything from setting environment variables to getting GPG set up, setting up a key server, receiving keys from the uncloud key, right? Adding groups, adding users, doing a soft link, like all of that's just basically. To Docker, it's just one long layer of changes, right? And so then the rest of these will most likely be stacked into, that'll probably be a change. That's a layer right there. That's a layer. These will probably be layers as well. And so you're probably looking at a 5, maybe 6 layer setup here. Because typically, those might actually cause layers. I actually haven't tested to see if environment variables actually set up layers. I know that run, workdir, and copy commands all set up layers, right? And so you just try to keep that as slim as you possibly can. Command and entry point setups don't typically cause layering, right? Neither does maintenance labels. And then of course, this is a source layer. So that's a base layer in itself. Okay. Back to this. All right. So if I were wanting to basically, let's say I tagged an image and I want to copy that image from my local cache and stick it up on a repository of my choice. Where would what command would I run after Docker?
Wouldn't you tag it?
That's right. I could tag it, right? I could tag the image, but what's the raw command, right?
That's
so I can do it. Push, exactly. And then push, and I can either put the long name on the repository, right? Oh man, maybe I'm also not awake this morning. And then put the image name, right? It could be whatever, right? I could do it that way. All right, so Docker pull, Docker push, right? What if I just wanted to list all the Docker images that I have on my local cache? What would I type?
Images.
That's it, right? Images actually list everything that I have, as you can see, right? If I were to, assuming I can spell Ubuntu correctly, if I were just look at all the Ubuntu ones that I grabbed, notice that I actually have an explicit 2004 image and I have an explicit latest image. As you can imagine, they look exactly the same size because they're exactly the same image. So there it is, right? Okay, now, what if I'm like, you know what? I actually want to get rid of every image that is just dangling, that's unused. What would I type if I wanted to get, like, clean up my system? I've got 1,000 images. I'm eating like 10 gigs worth of space. What do I need to type after images if I want to get rid of all my images that are being unattached and unused?
You can do a few things. System control prune all, or you can just do images prune.
Right, just to prune, right, for example. Now, notice that I can do all, right? Or I can actually like set some filters, but there's not a whole lot. Or I can just set it quiet if I actually don't want any output because I'm running it as part of a script, right? Now, if I want to build and I have a Docker file, let's say I have a Docker file right here. Actually, let's not do that. Oh, that's right. Let's say, and this is actually fine for me to mess around with. Let's say I have a Docker file right here, and I want to build that Docker file. What do I type in the command line?
You have a Docker file and you want to build a Docker file?
Yeah, I just want to build it. What do I type?
I mean, you could echo and pipe in something, or you can gedit it, or.
Well, I don't want to edit it. Let's say it's a legitimate Docker file. It already has a from in there. It has everything set up. What do I want if I want to like build the image that this Docker file could build?
You can either specify the dash flag, dash F for the file, or you can do the dot at the end, but Docker build dash T to tag it with the image name, and then colon for if you want a version, and then dot so it says this directory, or you could have done F and specify the file.
It found a Docker file, by the way, but it was like, hey, there's nothing in here. That's correct. Good. All right. By the way, what if I wanted to save a Docker file to a tarball? Does anyone know how to do that? Like I wanted to export it out. Like I wanted to pull it out into a file. Someone know by chance how to do that?
Pull a Docker file into a tarball?
No, to basically take an image to a tar file.
Would you use the export?
That's right. You can use Docker export, right? That's one of the ways to do it. And right, just out, basically, you can actually write it this right to a file, right, by doing the -o. Or the other thing, yeah, the other thing you can do is that there's also a save command, right? That you can do, like let's say we did nginx, and I can actually save that to an nginx.tar.
Nice.
Right? Now, by the way, what do I do if I want to load an image file from a tar file? What do I type?
Import or load?
That's right. Actually, I don't know that I've ever used import, honestly. Let's see. Yeah, I guess that is the thing. I guess import is another way to do it. I've never used import. I've always used save and load, probably just left over from prior art. But yeah, so import will definitely work. I don't know the command flags for that, so Docker import, add a Docker file instruction to the created image. Oh, that looks cool. Set a commit message for the imported image. Oh, that's cool. I like that actually. Docker load.
Or you could go to log.
Oops, sorry, Brad, you broke up there.
It's okay. I was just gonna say you could do the long way and upload it to a registry and then download it that way.
Well, how would you? Yeah, how would you upload the tarball to the registry?
I think I'm looking at the list of commands here. Let's see.
I don't
would it
know
be
if
push?
the registries.
It'd be push.
Well, that's a good question, actually. Is that does push support tarballs, or does it only actually support tagged images that are in memory cache? So from my
Oh.
understanding, it only supports tag memory that are in memory cache. It actually wouldn't support a tarball. I don't even know. It doesn't even seem like there's a flag for that, but I don't know. I actually haven't done it. That might be something to test out. But I think by default, it requires that kind of like proprietary OCI format that it's got on the thing.
What's a good use case for this?
Sometimes if like just to say this is obviously you should be able to back up your registry in some other form or fashion. Sometimes people will want to like artifact them off, and so they might use it for a backup use case. Honestly, most enterprises I use like will not actually export them out to a tarball. So I'm not actually originally sure like what the original use case for being able to have a tarball was, other than just being able to actually pull an image out of the repository and like share it. But even then, it like makes you question like the security implications of like, should you be pulling that out? Which is, I think, another argument for making sure that you use secrets and vaults and other things inside of your images. So nowadays, I don't think there is a good use case actually for tarball other than just informal sharing. Or some like you've got your own local image, and you're like, hey, I want to share this with somebody else, but you don't want to post this on Docker Hub. You can just send them the tarball, right?
What about if it was like a part of a build process that upon build it produces artifacts for S3, and then the build job pulls in the tarball to save it to the registry? I think that's an extra step, but
Yeah, and I think that's similar to the use case I was talking about, where you need to traverse some kind of registry boundary where someone's not going to have access to the registry. Like,
right.
Like for example, like you might pull it down out of ECR in order to put it into other ECRs in other regions. I could see that, but then also I think like for example, a lot of those use cases, if you have write capability to both, you could just pull it off of one and then post it in the other. So you wouldn't
Probably
necessarily
helps with air gapped.
Air gap would probably definitely be another use case. And actually with OpenShift, there was a lot of air gapping actually. So that might be a good use case. But anytime like you need a transfer boundary where you either cannot get access to both registries or you're just informally sharing. Because like a buddy of mine, Chris Kelly, works for a company called Echo360. We like trade back images back and forth. And he's like, I'm not going to get access to his registry inside of his house, right? It's not going to be shared. Sometimes we think about posting it up on hub.docker.com, but like Docker Hub, they're starting to charge and rate limit for stuff. So we had to switch gears on that about a year ago. Okay, so I think we covered briefly tagging, pulling, pushing. We talked about building, which is pretty straightforward and simple. And then we did save, export, and load, import. So that's pretty much image management. The only thing we didn't really cover is how do you remove an image out of your thing? Like for example, if in your local cache, I needed to get rid of, for example, Ubuntu latest, what would I type for that?
Would you do RM or RMI?
RMI. Yeah. So in this case, it would be RMI, and then I would just put in latest, and then gone. Right. So we go back and look. Ubuntu latest is gone. Okay. Good. Yeah, I think that was the only thing that we were missing. All right. So what if I wanted to run an image? Like just like, and we're going to pick on Nginx because that's the most common one that most people use for a use case. But what if I wanted to execute an image, run an image, get an image to start? What would I do there? Docker what?
I'm about to mix up Docker run and Docker exec. Is run for a new container and exec is against a currently running container?
Exec is typically against a running container, yes. So exec is when you want to start exec is for when you want to start a process inside of another container. Well, I say that with a little bit of hesitancy because it used to be, oddly enough, that when you ran exec, it would actually run the container if the container wasn't running. It doesn't do that anymore. A lot of the behavior of Docker has changed over time, especially the command executable. But let's say run, right? And then we just type in the image name, right? Now, what's going to happen with this?
It's going to run the container, and you won't Will it take away your console?
Yeah, I mean, it's
think
pretty much eating my console at this point, right? It's
you have
it's
to
in the
do a
foreground, right?
detached.
Yeah. All right, so how do I run it detached then?
-D.
Just that simple, right? And
Well,
then
if you wanna-
now you'll see the Nginx is actually running in the background.
I have a question about restart. Does it also start if it's not already paused or running?
I mean, if I go and
Can
stop
it-
Nginx. Oh,
Yeah.
sorry, I didn't actually choose the name. I should have. So if I stop Great Austin, which is the name of our container, and if I do a Docker, and you said restart?
Yeah, I'm just curious to see if that would also.
It works just like it does with like systemd, right? If it's not started, it's gonna start it, right? If it's already stopped, it's not gonna throw an error or anything.
Okay.
Yeah. Good.
Now, could you add the dash interactive terminal in the Docker runs for it to, or that's only on the exec?
All right, so if I do a Docker run and I dash the D and you want to do interactive that?
Yeah.
if
I haven't done it like that, but yeah, it's probably the same thing. Yeah.
Well, detached by default just means it's going to run in the background, right? So it's
Okay.
not, yeah, it's not going to create a terminal in this particular case.
Okay. That's only with exec.
Yeah, so in this case, like if I wanted to exec into it, just showing that like the other commands, what I would do is I would actually Docker exec and then got my brain, IT, and then in this case I would type in Great Austin, right?
911 or yeah.
And then, or yes, I could actually do the container ID if I wanted to. And then what do I type after this? What's going to be the thing that I type after?
A shell or bash or PowerShell or
Yep.
CMD.
So I'm going to try bin bash and see if that works. And then looks like it does, right? Sometimes, by the way, people just put bash in there, and that's also is fine. My host name is the container ID, which in this case is the V8. So this is Great Austin. So, and by the way, you don't just have to exec bash. You can exec whatever you wanted to, right? If I wanted to do, cat tmp, right? It'll say, oh wait, cat Tim's a directory, right? Well, maybe instead let's switch to ls. Now there's nothing in temp, right? What about var lib, right? I can actually execute commands in there. Now, just to be clear, the command has to be inside. Otherwise, you'll need to do something like attach sidecar proxy or copy the command in there, like busybox. Like you could copy busybox in there. Busybox as an executable will get you probably most of the commands, if not all the commands that you need. And then you could literally like remove it out when you're done. So just know that you can insert tools and remove them. This is like Kubernetes is starting to do this with ephemeral containers with like sidecar insertion to kind of like insert sidecars that have all the tooling that can then talk to the container in question. I think that's a great concept. It's also super complicated. You can just copy the tools you need and then pull them out when you're done. Or redeploy if you have multiple instances of it. So run will run it, exec will exec a process inside of it. Just remember that since this is process virtualization, you do have to have the binaries inside that you want to execute. And that's what the Docker copy command is for, right? It's for copying files in. Okay, let's say.
What can you do with that copy? You can copy like a executable into the container?
Mm-hmm. Yeah.
Okay.
Yeah. So like if you wanted to copy busybox into a container or even bash, if that bash wasn't in there, you could copy bash into the container. Because maybe you took it out because you want the thinnest container possible. Or, let's say you're troubleshooting a Windows container, you could copy some kind of sysinternals, right?
When you do the copy, do you also have to set the paths for everything? Like if you have an exe and you want to be able to execute that, when you copy, do you also have to set paths inside the container?
Yeah, typically you're going to want to go into a well-known executable path. like at least this is the case for Linux, and I believe it's true for Windows in most cases, is that you're going to you probably want to copy it in a common location like System32 or some other location that allows execution.
Or
It
like
just depends.
/user/bin or something, or sbin or something. Okay.
Yep, absolutely. It needs to be in a kind of a well-defined path inside the system. Just to be clear, since it's not running a kernel, that obviously you can also just set an environment variable if you go in there, or you can specify the full path. So if you specify the full path, then pathing isn't necessarily an issue. Yeah. Okay. So the copy command is very useful. Let's go back to run for just a second. If I want to run Nginx on a port other, actually, you know what? Let's back up. If I want to actually name Nginx, if I want to name it, I don't want to just go with Great Austin or Stupefied Morse. What would I type in if I want to name the container something different?
--name.
That's right. Just that simple, right? And so I'm going to choose something simple, in this case, web, right? Now I'm going to kill that because it's in the foreground. But let's say I do that same thing and I just do a -d for detached. Oops. It's already in use. Let's do web 2, right? Good. Now, if I want to do this same thing, but I actually want to run it on a different port, what do I need to put in here?
Would you do port number? I'm just guessing. I don't know.
No.
Would it do
Okay.
-- port?
Well, let's try it. Let's try -- port, and let's say, remember, first is always host, second is always container, right? That's true for volume mounts, and that's true for ports as well. So let's say I wanted to do 8090 because I don't know that I don't have that bound. I think I have 8080 bound already on port 80, and I do that. Well, it doesn't know what port is, so maybe it's -p. And there it is, right?
You can also do something crazy and do, instead of the port mappings, just do a -P. But that's can consume a ephemeral port or something.
What port did it connect to?
That's a good
You
question.
have to
So,
do docker inspect F7.
so see, this is that it actually grabbed 49153.
Oh, yep.
Yeah, for web 4, because that's the one I just ran, right? It was web 4.
Yeah, wow.
Yeah. So what that does is it basically just grabs a random port, correct?
Right.
Yeah. So, so no matter what I put in there, it basically just grabs a random port on whatever was exposed. So if I have a bunch of exposed statements inside of my, inside of my Docker file, and I run the -p, it's going to attach all of those to a random port. So good. Okay. Let's see. We already did background. We already did interactive. We already did naming. Volumes. So what if I wanted to map, for example, let's just make sure this is all cool. That's all right. It's on my local system. We're fine. Let's say I wanted to map temp in to that run that I just had and actually I'll just leave that. Let's say I wanted to map a drive in here. What would be the flag for that? Because one was --mount, which I said was actually the preferred way because it sets the type. What's the shorthand way of mapping a directory?
-v.
-v. Okay, cool. Now remember, it's always host first, colon, and then the actual directory inside. So in this particular case, I could do /temp and then colon, and let's say user share Nginx HTML. Oh, wait, that's right. I already used that name. Let's specify another one. Right? And then if I basically do a kubectl, oh God, sorry. That's obviously way too much Kubernetes in here. If I wanted to get in here and exec into web 5, right? Basically what I would do is I would do an interactive exec, and then I would type in the name. In this case, let's say web 5, and then I would do bash. And then what I could do is I could go look at user share Nginx HTML, and voila, all good, right? Easy mapping. Now, what if I wanted to do the same thing, but I wanted to do a volume? What would I change here?
Do you have to pre-create it with a Docker volume create? And what if that collides with the directory name?
Exactly. Well, let's find out. Let's try that again. Well, first of all, hold on. Let's do this. Let me go into root. Let's see, is temp there? Okay, temp is there. All right. So what if I do the same thing to answer your question and I collide with a directory name? So I'm on web 7 and I want to come out here and I just type in temp. I don't put a directory structure in there. What's going to happen? What did it do?
It made a volume.
It made a volume. Right, because it requires that basically if it doesn't have a leading /, it assumes that basically it's a volume.
Full paths only.
Full paths only. That's exactly right. So, and notice that you didn't have to actually pre-create the volumes. If you didn't have it, it just made it, right? So you don't actually have to pre-create them unless you want to. Okay. Let's see. So we covered mount. We did entry points on Docker exec. Oh, that's a good one actually. What if you don't want it to use the entry point to start? What if you want to change the default command that it runs? Like you don't want it to start nginx, for example, or you want it to like add some kind of like change to nginx. What would you add to Docker run? Sorry, I'm going to add IT in there just to make it easier. What would you actually add into the command to change the entry point command? The like default executable.
Would it be entry point?
Yep,
Or...
just that simple.
Okay.
Yeah. Want to catch you because your thinking is right on, right? They try to make it as intuitive as possible. Like in this case, let's say, instead of running nginx, I just wanted to run bash, right? Guess what? That's a way to get right off the bat, right? Now, the other question though is nginx running? Right? Oh God, there's no PS command. Really? Oof. I guess I could
be working in containers.
Seriously, I guess I could try and cap the processes, right? I don't know. I don't really want to go that deep into the meta. But my point being is that this is how you can exec a shell and change the default entry point command. Oh God, it's been a long time actually since I've been in proc. Actually,
would it be like system control or something and status?
That's definitely not installed.
Yeah. Sissy.
Yeah, it's not there.
Yeah. Huh. And a problem for another time. All right. So let's see. Let's see what we got running right now. We should have quite a few. Good. Okay. Let's see. We did copy. We did exec. Oh, what if I want to change the name? I forgot to name a container. Let's say Great Austin. I forgot to name. What would I type to rename it?
Is there a rename?
Or just name. Can you get multiple names on these things? I saw it was pluralized somewhere.
There's a rename.
Yeah, there's a rename. Let's try rename. So let's say I took Great Austin. Assuming I can spell Austin correctly. And I named it to cool. Awesome web server. Just that simple. Is there another command? If there is, I don't think I use it commonly.
Is it update?
MV.
Oh, that might be interesting. Update.
I don't know.
No, that actually maintains things like CPUs and memory. Oh, actually, it's probably worth talking about. You can actually set memory limits and CPU limits one little gotcha around the CPU limits, they're base 1024. So it's not milli CPU like it is with Kubernetes. So just be aware that if you do decide set CPU limits, it's base 1024. It's not base 1000. But you can set memory limits, and you can actually say I only want the odd even cores or whatever. You can do that as well. Just be aware that it can still see all the cores, but Docker is just limiting it to certain core consumptions. I think that's the main thing. Oh, actually, probably the other thing is that Docker top is really cool because it'll actually see like the running processes of a container. You can xargs that if you actually want to pipe in a bunch of like containers at one time. Let's see what else. Oh, Docker events.
What does Docker trust do? Sorry, go ahead with the events.
Docker events, and actually there's no events on this particular system, but it would list like significant events, especially if you had Swarm enabled. Wait, what was that? Docker trust? Is that what you said?
Yeah.
I don't know that I have trust on my system. Was that a subcommand?
Let's see what version this is.
Sorry, Docker stats is what I was thinking about, not Docker top. Docker top just gives a snapshot. Docker stats actually runs everything in real time. So notice that it's relatively static. But Docker stats is great because you can pass xargs to it. You can list all your containers with a certain tag if you pass them as variables. So you do have to control C out of that. I don't have a Docker trust. Oh wait, I do have a Docker trust. I don't know that I've ever signed like an image. Like I don't know that I've ever done that. But it's basically to enhance authenticity and authentic. Like,
nice.
Yeah, verification.
That's what we would need. We would need any of our images signed before we used them.
Yeah, I've never signed one, but there it is.
Does VeriSign sign, or like a company like that sign these, or do you have to come up with your own certificate?
Most of the official images will be signed, actually. So, yeah, and you can actually verify the signatures, and they'll also give you a hash. You can verify that way as well.
Could I see a Docker diff for images? Like, see how easy that is to use if you can follow. It's diffs to me are sometimes difficult to look at. I just want to see what it looks like.
All right, so let me go in and modify an image. Yeah. I don't know that it won't care about that, but let's see. So what it does basically, it says here are the things that here's the original, and then here is the thing that was added, right? Basically.
Okay, so what is C? What does that mean? C
like the core container, like the root, if you will, like the original piece.
Okay.
And then the A was the thing that was added.
Okay, append added. Okay.
Yeah.
Okay.
So it just shows you the files that were added. It doesn't show you the contents of those files. It just shows you what was changed.
Thank you.
Yeah. Let's see. I don't know that. Oh, Docker search. So if you have a repository pinned inside your setup, it's like, oh God. So Docker login, and by the way, just so you know, I already have logged in, so it's already in my Docker. Like there's a config.json that contains username and password. I already have it authenticated, so this is why it didn't actually ask me for username and password because I already logged in. But Docker login will log you into hub.docker.com. You can specify a different URL if you have to log into a different registry, but by default, it assumes hub.docker.com. From here, what you can do is like if I'm searching for Postgres, as an example, it will allow me to, from the command line, to search for images. Now, the only thing I will just mention with this, right, is that I would prefer to only get official images. So I don't remember this off the top of my head, but there's like a way to set up filters that says, I only want official images. So if you ever do this, you know, obviously if you're in your own repository, this is not a big deal, but like be very careful with this. If you decide to pull down images from hub.docker.com, you really only want to pull down single name images and not name slash images, because name slash images is probably not the official vendor image, as you can see on the right hand side. So
I have a quick question on exact. So you let's say you copy over an exe into your container, but then you wanted to run an update on that, but you didn't want to do a complete new copy or replace of that application. Is there a way to update it?
like you wanted to update the application inside the running container, but you didn't want to restart the running container?
Yeah. Well, that's
So-
one scenario.
So just so you know, like the trickiness with that is that containers typically center around one core process. So like if you had a supervisor of some type running your application and you wanted to replace that application and restart it and the supervisor didn't bounce, you'd probably be okay. But if you bounce that supervisor, the container is going to be considered failed and it's going to restart it anyway. So that's why you typically don't replace running containers like processes. You don't like on the fly like change them. You typically drop the container and restart it, right? Because if you kill that core process, the container will fail, and so it's gonna bounce it anyway. So typically, you're not going to update a container on the fly. You're going to drop the container and restart it, and then the restart will contain the new version. But if you had to do that, you could use the copy command to copy in a new version of your application, but you'd have to bounce the existing process that was bound to your executable and start the other one. And so that would be fraught with peril. You'd have to have a supervisor in place. Because again, the minute the core process, the number one process dies inside of a container, the whole container is considered failed and it's gonna drop the container.
Okay.
Yeah. Good. All right. Let's see. Let's switch over to this really quick. Where are you, sir? Let's see. Did I misplace you somehow? Nope, not the CIS benchmark, not the Windows container conversation. Where are you? Oh, here we are. That's right. Okay. So just to refresh our memories. By the way, any questions about any of the Docker commands as far as run, exec, push, tag, any of that stuff? Pull, save, load. Okay. All right. You might remember from our discussion yesterday that we were talking about OCI, and just to throw this out there, so this is going to be a little like free form arrangement here. What do you remember as being the base? Here, I'll do this. So let's say this is Docker. Let's say that this is Kubernetes. We're going to just copy this because, that's why. All right, so this is Kubernetes. Now, when we went to schedule a container to run, there was a particular piece of software that actually acts as a supervisor / orchestrator. And there's actually several different versions of it, but both Docker and Kubernetes use this piece of software to kind of orchestrate for containers. What was the name of that like supervisor kind of like runtime or like container runtime in a sense?
Container D.
Right. Good. So Container D was basically the core one that both of these guys could use. Now, what was the other one that I said was primarily used by OpenShift?
Creo?
That's right, Creo. Creo was the other one, right? Yeah, sorry. In my brain, I was remembering where the dash goes. All right, so in this particular case, Docker is going to talk to Container D. Kubernetes can talk to Container D. Kubernetes can also talk to Creo as well. But then what's going to happen is that, and there's API servers and other things in place, so don't let me fool you. There's actually other components here, but we're just for simplification standpoint. Now, with this being said, what ends up happening is once it hits container D and container D knows that it needs to run a particular flavor of container runtime, originally Docker would insert something called a shim, basically, to act as a kind of an interface between it and the native container runtime. But then that was removed in 1.20, at least with Kubernetes. And by the way, it now uses, and it has for a while now, actually, it uses a smaller container runtime library to actually run its containers. What is the name of that smaller container runtime library? It's not container D. Run C. There we go. Good. So run C, right? And actually, I didn't capitalize the first letter. Run C is actually right now the container runtime. And then what that does is then that actually starts the running container, right? Because this is the container interface. Now, all of these container runtimes are what compliant? What is the term?
OCI.
That's right. OCI compliant, right? And that was a consortium of a bunch of different like places and like locations. By the way, container D, who owns container D? Anyone know?
Google.
So it's actually owned by the Cloud Native Computing Foundation.
Oh.
Yeah.
Donated to them by Google.
That's right. It was donated to them. Well, yes. Yeah, for the most part. By the way, the CNCF, by the way, has a bunch of awesome projects, most of which are defining the future of the IT industry. So I'm just going to skip past a bunch of stuff on the right, so just ignore that. These are all the official projects that are part of the Cloud Native Computing Foundation. If you're ever wondering, you're like, I wonder what I should invest skill-wise next in building. Most of the time, you cannot go wrong by investing in one of these products, particularly if it's being like talked about a lot as core. So you'll notice that Creo is down here under container runtimes, along with container D, which is also down here, right? Notice that one of them is graduated and one of them is kind of like incubating, right? There's a bunch of graduated projects, and if I just filter based on graduated projects, you'll see some of the most famous, pieces of software, at least in the last 5 years. Helm, etcd, Core DNS, Kubernetes, Envoy, which forms the core of almost every service mesh that we use from a sidecar perspective. Container D, I can't remember what the TI and Vitness are. They're databases, but I've never used them. So is etcd, so it's a little weird. There's Harbor, which is an open source container registry. I think it was contributed by VMware. And then Open Policy Agent and Tough, which are really about security and compliance. OPA in particular is really, it uses this Rego language. And I think it's actually fairly complicated, but it's becoming the de facto way in which we control admission and execution policies inside of Kubernetes clusters. So it's become quite a staple. And then, of course, we've got other famous things like FluentD and Jaeger. Jaeger's used for tracing, like for tracing processes and visibility. So just know that out of just the graduated projects, you've got kind of the best of the best. But Container D is down here, under, there's Container D under container runtimes. And if I add in the incubating projects, you'll see that Creo shows up as well. And there's things like the CNI and CSI, all part of what we're going to talk about with Kubernetes for the next couple of days. Good. Good. We're going to do this exercise again, but later on, we're going to do it with Kubernetes, just to make sure that we kind of get those pictures cemented in your brain. Does anyone have any questions about anything we talked about yesterday before we move on to Kubernetes content? Oh, thank you, Tom, for posting that filter. I couldn't remember it off the top of my head. That's good.
The stars is definitely optional, but when I looked at the stars for Alpine, it's like 7,500 stars. So I don't get why.
Yeah, definitely make that happen. Yeah, I think the one we were looking for Postgres had like 9,000 stars on the official. Yeah, that's good. Equals 3 Alpine. Let's give it a shot. Probably would help if I spelled official correctly. There we go. Yeah, same for Postgres. Yeah, Good.
Would not like to program this interface right here. No, it's not like fun.
Yeah, not at all. Okay. Other questions, comments? Okay. Good. About the same length as we expected it to. Let's see. Did Jonathan join us? Let's see if he's on the list. No, he's still doing his thing. Okay. We'll go ahead and cover Kubernetes, and I will forewarn you, like this first like couple of like hour or two, the morning is fairly lecture heavy, and then we're going to spend a lot of time in labs actually this afternoon once we get past the list lecture. So we're going to talk about Kubernetes like architecture, which is very in depth. It's kind of like talks about all the like core components, and then we're going to talk about working with Kubernetes, and we're going to talk about the different Kubernetes workloads, which includes things like deployments, stateful sets, batch jobs or jobs, cron jobs, and anything else associated with that, like replica sets and whatnot. So that's what we're going to do for the next couple hours. Okay. So Kubernetes is basically Greek for helmsman or pilot. You know, Joe Betta, Brendan Burns, and Craig McLuckie are considered to kind of be like the original founders of this. Brendan Burns is probably the one that I'm familiar with the most. Brendan actually worked at Sun before he ended up landing at Google, and Brendan is the guy who was known as like finding out that vibration affected physical platters on hard drives. And there's this old video of him screaming into a disk array and causing IO stat to throw all these like latency parameters up, because he figured out all the latent sound inside of a data center, obviously for disk platters was causing a bunch of issues. So that's when I actually first heard of Brendan, like way back in 2000, whatever, 6 or 7, whenever YouTube was just on the rise. But Kubernetes is commonly referred to as K8s because people don't like typing in the 8 letters between K and S. So it is open source. It is free. You can download it. But again, just like a lot of open source, it's free as in puppy, not free as in beer. And so, you have to be mindful of the fact that there is an investment in a learning curve. For people who want to really understand the internals of Kubernetes, my best recommendation, and it still stands to this day, is that a gentleman named Kelsey Hightower developed a repo, which he actually still maintains actively. Like it's maintained up to date. But Kelsey Hightower, who's a developer advocate for Google, maintains a repo called Kubernetes the hard way. And if you've never done Kubernetes the hard way, it does require almost free tier access to the Google Kubernetes engine. But you can't actually try and run it under other circumstances. You just need to make some changes as far as the instructions go. But this walks you through step by step how to manually set up Kubernetes, including the tools, generating certificates, the different files that you have to configure, how to set up the etcd cluster, how to set up the primary leaders and masters inside the Kubernetes cluster, how to set up work nodes, all of these pieces, including provisioning network routes, adding DNS setup, smoke testing, and then cleaning up. So I've run classes where we just spend weeks running through this, and we meet every week for an hour to kind of review and walk through steps. This is probably one of the single greatest resources to really understand how a Kubernetes cluster functions. Now, hopefully you will only do this here and you will never set it up manually, because there's lots of great tools like Kops, and Rancher has a great setup tool. OpenShift obviously does all this for you, because Kubernetes is just one of 300 open source components in OpenShift. And if you're using a managed provider, you wouldn't do this at all. It's all done for you. But this is one of the greatest ways to understand the internals of Kubernetes.
Kubeadmin.
I'm sorry, say it again.
Kubeadmin.
kubeadm, yes, yeah, kubeadmin.
Yep.
Yeah, kubeadm is the other way to add worker nodes and simplify additions and instructions. But this really gives you full ingrained detail on how to set up a Kubernetes cluster from scratch without all the tools, right? So Kubernetes is basically a container orchestrator, and it's most often associated with Docker because Docker is most often associated with containerization. People are still confused out there in the wild about, like, do I need Docker if I'm using Kubernetes, for example? And as you probably well know now, is that Docker is just a containerization format in a sense, and Kubernetes is going to eat that format and deploy it out on its systems. So it's used basically for automating deployment, scaling, management, resiliency, high availability, fault tolerance, right? All kinds of stuff for around containerization. It is a container orchestrator. It does actually group application containers into logical units that contain typically one, sometimes more than one, but typically one container. It's designed to scale applications easily, and it can be implemented either on any platform that has an operating system, particularly with a kernel that's 3.10, 3.1.0 or later, which I think 3.10 is like 5 years old at this point. I'd have to look that up, but it's relatively old. So you'd have to be running something that would be 4 or 5 years or older. It can be deployed on bare metal machines, but that's kind of a misstatement because you need an operating system. So Kubernetes will not install without an operating system. It is an application. It is not an operating system. There are projects to change that, but it needs to actually be installed on a virtual machine or a physical box that has an operating system on it. So don't let that last line fool you. It can be deployed on bare metal if there's an operating system. Now, its primary focus is container orchestration. So it does everything for you that it can about how to distribute containers over a set of boxes, a set of, in a sense, nodes, application nodes. So it's got workflows, right? It doesn't matter if the machines are physical, virtual, none of that makes a difference to it. But if it sees a container die, it's going to restart it or replace it based on whatever declarative statement you've made about your containers. So it basically, the focus here is it's basically around container distribution. Obviously, it's very useful for microservices, which is something we've talked about before. So in this particular case, let me blow this up a little bit because that's a little bit of an eye chart. Is that here we've got what's conceptually in our minds is a Kubernetes cluster. Now notice that there's a control plane, and that control plane has different components in it, including a controller manager, a cloud controller manager. It's got an API server, which controls all of the interaction with all the other components. It's got an etcd database, and then it's got a scheduler, which does scheduling out on the nodes. Now, this is an interesting kind of setup because the nodes themselves, all they really run is a kubelet, which is used to interface back with the API server, or, sorry, or they're interfacing in with the kube proxy, which it controls like a lot of the networking and does some proxy. So if we go back to our drawing over here for a second, the thing to think about is that within a cluster, there's going to be this whole logical derivation, right? This whole thing is actually going to end up, in a sense, being the cluster. And so if we think about this from like it's all of its different components, the first thing that you have to have is you have to have what's called either a master, or we sometimes are referring to them now as primaries, right? And you can have it, you have to have at least one primary, but you can have more than one if you want to. Typically, max in production is to run 3 because this uses a kind of quorum method of determining elections and leadership. So typically, you either want 1 or you're going to want 3. You typically don't necessarily need more than 3, but it depends on what your setup is, because if you're in AWS, for example, you might be running across 3 availability zones. And so you might actually like run, like you might have 4 or 5 or 6. But just to say this is that you typically want an odd number, so that if something split brain happens or if someone loses contact, it knows it's not authoritative for the cluster and doesn't start trying to make any changes. Okay, so typically you're going to have what is called as 3 masters. And like if we look at one of these masters in detail, what will happen is that on this particular master, you're going to have a bunch of different components on it. And so You could have a component, for example, of the API server, which we referred to before. And let's actually make that a different color, just make sure it stands out, because yellow is so awesome. So you're gonna have an API server, and the API server is pretty much the king of the components that are actually on the primary system. So it's the one that's you're gonna talk to pretty much do everything else. You're then gonna have what's known as a controller manager. And the controller manager is basically going to try and make sure that it knows about the status of all the other components, sets things up. It's going to like make sure that everything's running and working. And then you're going to have all this state for this cluster is going to be maintained in what's called an etcd database. Now, etcd is a NoSQL database. So as you can imagine, there's going to be an etcd database on this master, the second master, and the third master. They're going to maintain quorum and state with each other, so they're going to like eventually be consistent with each other. So there's going to be an etcd component. If the system is on the cloud, there'll actually be what's known as a cloud controller. And what we'll put there is it depends on what cloud provider it's on, right? If it knows what cloud provider it's on, which you can tell it these things, it's going to interface with that cloud provider to create objects on the cloud provider like load balancers. It's going to manage networking, request IP addresses as well. And last but not least is that when you go to schedule on these systems, you're going to have a scheduler. And that scheduler is what's going to do all the scheduling on where actually all the work is actually going to exist. So if you think about this as basically being a subset of the master setup, what happens over here is that you're going to have a bunch of nodes. And these are, you could call them application nodes or worker nodes, but these are all nodes that host basically pods. Here, let's pull that out just a little bit. Okay, now on these nodes, what's going to happen is that you need to have something that's going to talk back up to the API server and talk through the API server to all of the other components, right? Because the API server is also going to initiate connections out in some cases. And so you're going to need components on here, but you're not necessarily, you don't need the same components that you had on the master, because these application nodes are hosting pods. So if we look at this, and we're going to make this a slightly different color just to make sure that we are aware. On here, you're going to have what's called the kubelet. And then you're going to have the kube proxy. And then additionally, you're going to have whatever runtimes you need are also going to be over here. So one of the runtimes that we've been talking about a lot is runc. We might have other runtimes out here as needed. And why are these runtimes going to be out here? Because this is where we're going to run pods as well, right? So kube proxy, by the way, is going to network with all of these other boxes. The kubelet is going to talk to the API server, the controller manager, and anything else it needs to, mainly through the API server, right? To basically let the cluster know what's going on. So you're mainly going to see traffic between the kubelet. Let me choose this. The kubelet and the API server. The API server is going to mainly talk to everything else, right? Controller manager will sometimes talk to things. The scheduler, by the way, will talk to the kubelet, because it'll say, hey, kubelet, download Nginx. Hey, kubelet, download Postgres version 1. Whatever, or I guess we're up to 13 now, right? Or Nginx 1.7.9. And so, by the way, yesterday I said a pretty shocking number. How many application nodes can you have in a single Kubernetes cluster according to like 1.18? Anyone remember what I said yesterday?
5K.
Yeah, 5,000, right? Again, it seems pretty ridiculous. I also said that in general, there's a limit, a soft limit inside of Kubernetes that you're going to get a certain number of containers per host. Does anyone remember what the soft limit was for that?
Was it 1 to 200?
It was 100, right? And OpenShift can support 200, but you can go in and modify that. Just be careful, because as you'll see as we get to the networking piece, you can easily overload a box just with all of the extra administrative overhead as far as like the storage and networking abstractions inside of a system like that. So just something to be careful of. Okay. So hopefully this shows is that really what makes up the cluster is just these three primary systems and all of the worker nodes that are attached to it. And that is actually the core of the cluster. These pieces here are just components inside either the masters or the leaders themselves. Okay, any questions about any of those components?
Yeah, what does the proxy do?
So the proxy handles all networking for the pods, the applications that are running out here, because this is where the apps are actually living, is they're inside pods, they're in the containers inside pods. And so the kube proxy handles all the networking between all the different nodes and to the external world.
Okay, so you're saying that, from what I understand, I was thinking that a node would go through the API service to connect to another node. That's not the case. It would go through the proxy.
Yes, if an application wants to talk to another application that's over on another node, then it would actually just talk directly to that system.
Okay, so this really isn't serving like an enterprise service bus. It's just serving as a manager to direct all the other nodes.
Yeah,
Is that right?
all the API servers is doing is managing all things infrastructure related to the Kubernetes cluster. Application application communication between apps is actually direct. So there's no middleman for that, unless you put like a service mesh in there. But even then, it's just redirected to something that just acts as a proxy. But otherwise, the API server is only called when there's anything related to the actual management of Kubernetes, not actually application communication.
Is this called the control plane?
Yeah, so the items in blue are called the control plane. The items in green are
Okay.
called the data plane.
Okay.
So that's the distinction. Yeah. So when people say, hey, Amazon or AKS, Azure, or Google, they take care of the data plane for you. I'm sorry, the control plane for you. What they're referring to is that they take care of all the master stuff. They take care of administering all of this stuff that's in blue. They take care of that. You don't, right? It's done for you. But you have to like manage the data plane. What they're referring to is they're referring to, what kind of worker nodes do you have? What operating system are they? Any patching or management, if you're doing an unmanaged system, that's all on you, right?
So when we configure, I guess we'll get into that in a second. We basically have to manually configure each node, right?
Manually configure each node. You mean in terms of?
Kind of. Well, we wouldn't just specify one node schema and then it would just reproduce itself or replicate itself. The nodes wouldn't replicate. We would have to explicitly say, okay, I need 3 nodes to have this configuration.
Typically what happens is that in the boot image for the virtual machines, when they're booted up, they are added into the cluster as part of the boot process. If it's in an auto scaling group, for example, or a scale set on Azure, you can actually make it so it automatically joins the cluster. And Kubernetes has cluster autoscalers. So it can actually talk to the cloud itself and add nodes automatically or shrink nodes automatically based on whatever metrics or characteristics you're looking at.
Okay, so if a node dies, it goes away and restarts.
It restarts it. Yeah.
Okay.
And that it leverages the native cloud functions for that. So it actually would put it in an auto scaling group. And if a node scales in an auto scaling group, it just restarts it. So using the same process that you use to do all of the other ones. So there's no like difference between them. And so you can actually scale like applications using a horizontal pod autoscaler. You can also use a cluster autoscaler, especially on a cloud provider, to automatically scale your nodes out as they, as you need to. Like let's say CPU utilization got really high, or you couldn't actually deploy an application because there's no more memory space. It would just add a new node for you and then deploy the pod in question.
And by node, you mean like a compute instance?
Yeah, in this case, whatever they call the virtual machines on the cloud provider. Kubernetes calls it a node. AWS calls it an instance, right? Azure calls it a virtual machine, right? I think Google calls it a virtual machine as well. No, it's an instance, right? So, whatever the parlance is, it's adding a virtual machine.
Awesome.
Yeah. Good. Other questions? Okay. So what you saw there was just a less blurry version of this. I'm not sure why it's not scaling, but it must be something going on with my system. But the API server's in the center over here. So you can see this right here. API servers here, cloud controller managers here, controller managers here. etcd, right, is in this little box. And then here's the scheduler. Note that the cloud controller manager is actually talking to the API server. And then note that on the worker nodes, there are kubelets and k-proxies listed here. The only thing that's missing is you're not seeing the containers or pods or the runtime stuff on these nodes. Good. All right, let's scale that back. All
Can
right.
you keep that image up a little bit longer? Mine's my view's still rastering for some reason.
Sure.
Come on. Oh, I'll have to refresh. Hold on.
Okay. At least in my book, it's on page 124. So if I subtract like 20 or 30 from that, it's probably about where we're at inside the lecture book. So a couple of things just to center on in terms of vocabulary is that whole set is the cluster, right? So all of this is the cluster. So the masters and the actual nodes are a cluster. Now, a node, right, or a worker node or application node is the physical or virtual machine that makes up the green boxes down there. So they're actually hosting pods. They're the ones that are limited to about 100 pods out of the box, and they're the ones of which there can be 5,000 of these little guys. And by the way, it can be 5,000 really big boxes. We're not talking about any vertical set, like the amount of processor and memory. It's just that you can only get 5,000 operating systems inside the cluster that can host applications. Now, inside each of these worker nodes is an app that's bundled into a deployment bundle that's called a pod. If we actually blow this pod up just for a second, inside this, you're actually going to have other, in a sense, containers, and there's typically only going to be one app container. Now, there might be other containers in here, but they're not going to be application containers. So the goal here is that typically within a pod, like this being like a simulacrum of app 2 right over there, right? You're going to have other containers in here, but this is going to be an operations pod. This is going to be a security pod. I'm sorry, security container, not a security pod. And so these little orange boxes inside the yellows that are over here on like app 2, for example, those are pods, but inside those pods, there's going to be containers. So you can actually run a bunch of containers if you want inside of a pod, but typically there's only one application pod. You might think, but Michael, why would you do that? If I'm running a WordPress site, why wouldn't I stick my web server and my database in the same pod, right? And the problem is scale. If your web server is overloaded, but your database is not, and you want to scale your web server, you also have to scale the database. And since it's a MySQL database, you're going to cause problems because you're going to scale a bunch of databases that are going to be out of sync with each other, right? You have different versions of your website, right? So imagine if you had multiple copies of this just floating around, and there was a database in here instead of a security pod or a security container, right? So you have to be careful in that keeping only one app container inside of a pod. So as you scale that pod, you're only scaling your app container. You're not scaling your app, your database, your search engine, your application. You wouldn't stick an entire product inside these little yellow pods. You wouldn't do that. You would just stick one application container.
So just real quick, when you build out your network, would you suggest like putting in like a IDP or an IDS, I don't know, some sort of security that would also be like a node that basically would be a front door or something to, or at least be on inside your cluster for network traffic? Do they do that like as a practice?
So some people will put like for example, a firewall, at the edge that's doing DPI or some variation thereof. And then sometimes they'll put IDS and IPS systems in line, like as far as like the egress for the cluster. The cluster itself, you can actually apply network policies using Calico and Canal and all these other kind of like systems. Tigera is another one that will allow you to kind of restrict, control, and filter how traffic moves in the cluster itself. In addition, especially if it's layer 7 traffic, people will stick web application firewalls to like filter that traffic. So there's a couple of different ways to kind of attend to networking traffic on a production level. There are a lot of tools to go into a Linux-based system, a Kubernetes system, to kind of like protect, scan, filter, allow and deny traffic from that perspective. It just depends on what your requirements are. Most companies I know at a minimum will run some kind of filtering firewall function outside the cluster, and they'll apply security policies on the networking inside the cluster. Because just so you know, the networking traffic that's inside the cluster can't really be seen outside of the cluster. So you have to attend to both of them if you want both traffic leaving the cluster and traffic inside the cluster.
Thank you.
Yeah. On cloud, I will mention that it is slightly easier because like all the cloud providers typically treat application containers a la pods. They treat them as virtual machines, even though they're not. They actually give them an assigned IP address from the internal network. So you can actually see the traffic go across the flow logs for the particular networking system in the cloud provider.
So would to potentially have a private IP address and an external IP address. Is that how it would work?
Yeah, so by default, all of the container/pods are going to get an internal IP address. It works just like a cloud provider. With a cloud provider, if you run a virtual machine, and it's the same with Kubernetes, you get a private IP address, even if you're actually on a public subnet. Because what then you can do is then you, at least on the virtual machine side, you can actually assign an IP address to that virtual machine, which allows it to have a private IP address internal to Amazon in this particular case. But then it actually has a public IP address that allows it to route to the internet. Kubernetes does the same thing. Every pod gets an internal IP address, but when it wants to externalize it, it actually creates another object called the service. And that service could be a load balancer that has a public IP address. And that load balancer acts as a proxy. So instead of assigning a public IP address to a pod, to an application pod, Kubernetes doesn't do that. It actually assigns a public IP address to another object that acts as a load distributor across the entire cluster. So Kubernetes tends to leverage load balancers, they call them services, as a means of distributing and externalizing public IP addresses versus the internal IP addresses for its various pods.
How would that work in the cloud where you have, you know, sets of data centers, you know, around the world with your clusters like mirrored at each location?
Well, when you say mirrored, what do you mean? You mean copied? Because they wouldn't be in sync with each other, right?
Well, in sync is what I meant. I'm sorry.
Yeah, I just want to make sure, right? Because like if they were mirrored, I'd kind of be curious as to what the synchronization method would be, because it is possible. But if you have different like ones copied all over the world, let's say you have, you know, GovCloud East and GovCloud West, right? You've got 2 Kubernetes clusters in each location. The main problem is that your applications are going to be independent except for their data sets. And so you have, and that's independent of Kubernetes. You have to figure out how to replicate the data sets across. But if you assign a public IP address to an application that you've got running on the east side of the United States, and you assign another public application IP address to the service object for the applications running on the west side of the United States, your DNS would just connect to the services on both sides, the load balancers on both sides of the equation, and they would distribute down to the pods that are inside the clusters. So DNS wise, your users would resolve to either east or west, one of the load balancer objects that's there as a service, instead of resolving directly to pods. You don't typically resolve directly to pods, you resolve to a load balancer object and it distributes it down to whatever pods you have. And that way the load balancer has a smaller attack surface, but a public IP address. And then you can actually restart the pod underneath the load balancer and the users typically won't know, because you haven't terminated the connection because the load balancer is maintaining connection, right? And you can horizontally scale really easily because the load balancer is just going to accommodate whatever number of application pods that you've installed into the system. So that's typically how it's
really
done.
Cool.
Yeah. Well, that's fair. That's staple, right? A lot of the push that you're going to see now, and I think Azure has this, but I don't think Amazon has it. Well, they don't have it this way, right? But I think Azure has it. The global traffic director in Azure will allow you to do global like IP redirection. Amazon has a version of it, but they mainly rely on DNS, which is totally fine. But a global load balancer is actually, from my perspective, a better way to solve that problem. Although DNS will handle 99% of use cases, but that's typically how it's done. And just to say this is that DNS will resolve based on geographical like nearness, like proximity, as well as latency. So if a user is, you know, in Canada and it's faster for them to go to west than to east, DNS will resolve them to east, and then they'll talk to the pods behind that load balancer. So
there's a additional load balancer, but I thought kube proxy had something to do with load balancing.
Only within the cluster. The load balancer handles stuff outside the cluster.
And that's outside of Kubernetes.
That's right. Don't get me wrong, it's integrated in with Kubernetes. And you can actually run an F5 or an Nginx as your load balancer inside the cluster if you want to. But when you're running on cloud, Tom, usually what happens is you just leverage the cloud's load balancer.
Right. I set up a application load balancer for ECS. And it's pretty tricky, but basically you just give it ephemeral port range and target register targets a target group basically to point to.
Right. The target groups, inside the target groups, that's where the pods are.
Right.
Yeah, and you have options. You can use a gateway load balancer, a network load balancer, or a application load balancer. The gateway load balancers, by the way, are where your IDS, IPS, and your like DPI for firewalls would go. Your deep packet inspection. That's the gateway load balancers are more for inline in-tap security. the ALBs and the NLBs, which are application load balancers and network load balancers, those are the ones that you would start for usage with pod applications. So ALBs is one option, but you could also just use an NLB. NLBs tend to be more simple, but they can handle a lot more traffic load. ALBs would allow you to path based on whatever the payload was. So if someone hit /mobile versus /desktop versus /Americas versus /Asia, they could actually go to different pods in your Kubernetes clusters, different applications, depending on what you had registered. So that's what typically the ALBs versus NLBs are used for.
Okay, right. You could do the prioritization of the path.
Right.
But wouldn't it be one for one type? Like one application balancer for one container application type?
No, with ALBs, you can actually have multiple. You can have one application load balancer feed out multiple applications based on path. So you can have multiple
Okay.
target groups behind an ALB.
But that would mean the DNS entry, at least the fully qualified, would stay the same. It's just the path at the end that would change.
Not necessarily. You can actually set the since it's a C name, you can actually set whatever you want. You just need to make sure the load balancer will accept it, right?
Right.
So yeah, you can use SNI for that as well if you want to if you're using SSL or TLS.
Okay, yeah, that's something I'm interested in later on. So
okay, yeah. Sorry, I don't want to go too far deep into that because I think we probably just lost half of our audience. So, guess it's good questions though. Yeah, but yeah, you can easily set up an ELB for that. I will say typically though, it is one-to-one. So when you have pods that are running applications and they're in a Kubernetes cluster, different types of pods, let's say it's app 1 versus an app 2 set of pods versus an app 3 set of pods, typically each of those would get a load balancer just to make it simple. But you could use one load balancer and have 3 different paths, one going to app 1, one path going to app 2, and one path going to app 3. So there's a couple of different ways to approach that. Okay, so in terms of terminology, and we're gonna take a break here in a second just to give our brains a break. I just want to make sure we go over the components, and then we're going to take a pause. A reminder that there was a request to stop around 11:30, probably a little earlier, so you could all do a meet and greet, which actually worked out well for me as well. So just a reminder that we will be stopping at 11:25 just to make sure everybody has some space.
That's on Wednesday.
Oh, it's on Wednesday?
no, it's today.
Oh, okay.
I don't have it on my calendar.
Oh, well, I'll send it to you.
Okay. Good with me either way. So, but it sounds like it's today. All right. So the other thing is that since containers sit inside of pods and pods sit on top of application nodes, all of the other things that we learned in Docker pretty much still apply. For example, you can attach volumes to a container inside of a pod. But the only thing to really remember, if we go back to our drawing, is that if we look at the app2 ops sec containers that are sitting inside of that yellow pod right there, they can all see each other's like inter-process memory. They use the same network stack, and any storage that's mounted, they can all see. So just so you're aware, in a sense, Kubernetes mounts them into the same kind of process space, if you will, and they can all talk to each other. There's very little security between containers that are inside the same pod, and that's fine. You want that, actually. You want to be able to trust. So if you have an operations container in there and a security container in there, in with the application container, just know that there's very little security between them, and they are actually going to be able to have the flexibility and permissions to see each other and talk to each other at will. That can be problematic from not from a security to app direction, but from an app to security container direction, where you're like, hey, if someone hacks this application, does that mean they can mess with my security container? Most of that's statically compiled anyway, so most of that's resistant to tampering. But yeah, no, it could be tampered with. So just something to keep in mind if someone were to somehow escape into the pod, right? But just remember, containers go inside pods. Pods are deployed on side of nodes. The nodes are the workhorses where all of the applications are actually running. So Kubernetes will manage the pod, not so much the containers inside the pod. They'll make sure they're there. They'll make sure they're running. They'll mark the pod as failed if a container inside fails. And you can control that behavior. But just know that at its core, if you're thinking about this, the core is the application, which is containerized, which is sitting inside of a pod, which is sitting inside of a worker node, which is sitting inside of a Kubernetes cluster. So app, container, pod sitting on a worker node sitting inside of a cluster. And I mentioned it to you that way because that's why networking is complex. We got an app sitting in a container, sitting in a pod. The pod and the container have their own networking, right? The pod itself is sitting on top of a worker node, which the worker node has its own networking. And by the way, there's a virtual bridge in between them as well. We're going to have a whole section on networking, so I'm just giving you a preview. And then the worker node is part of a cluster, which has its own networking. And then you've got people outside the cluster who want to get into the cluster, or you want to talk to people outside the cluster, and that has its own separate networking. So there's lots of different layers of abstraction here when it comes to networking and also security that are at play here. But remember, app, container, pod, node, cluster. So app, container, pod, node, cluster. Pausing for questions.
This is one more question that might be, I know, probably answered in the network section, but MAC addresses. Do containers have MAC addresses?
Mm-mm. No, and you can force a MAC address on a container in Docker by using the MAC VLAN option for network drivers, but typically they're not going to get their own MAC address, like in a Kubernetes cluster.
Okay. Thank
Yeah,
you.
they'll use the MAC address of the host that they're on.
So when a node is built or whatever, I guess it gets registered with the controller, with the master, the primary.
Yeah, it does. So for example, down here, all of these pods would actually be registered in the etcd database and their locations, and they would have been put there by the scheduler. The scheduler is the one who said, hey, I want you to go here. The kubelet on each of these worker nodes would then register what it has running and what was successful with etcd. So it's an interplay between kubelet and the API server. The kubelet and API server would actually make sure that etcd had the right state information. Good. All right. The other thing to know is that in addition to being able to share networking space, share volumes and whatnot, you can also take a cluster and create these little, like, in a sense, like vertical slices. Let me see if I can throw this in here really quick. So like if we were to make a little slice of a cluster, they call these namespaces, right? If we took a little slice of a cluster and we said, look, I want this to be my monitoring namespace. I want this to be my project A namespace. I want this to be my 3D printer namespace, right? What these little like blue slices here in this case represent is they represent a logical partitioning of an existing set of worker nodes. That's all it is. It's a logical partitioning of an existing set of worker nodes. It's nothing any fancier than that. And so what that means is that every node that's in that cluster, when you create a namespace, that namespace is on every worker node in the system. And it's a security partition that you can stick containers in, but you can also attach what they call roles, like kind of like users, into Kubernetes. So if you want to restrict a team to its own namespace, or they get access to 3 namespaces because they got 3 different product lines, you can actually create namespaces that allow you to segment out a cluster. And it's a really great way to basically create logical partition security boundaries inside of a cluster itself. And namespaces are one of the core technologies that actually make containers work in general. And so, like, for example, you might have a namespace for monitoring, a namespace for logging, a namespace for, you know, again, whatever product portfolio you have. You might do it by department. All of the developers in IoT have this namespace. All the developers in, you know, connected buildings, they have this namespace. All the developers who are working on, you know, extraplanetary exploration, they're in this space. It's like, it just depends on what kind of like organizational division you want to follow, or team division, or group division, or whatever makes sense to your design for your cluster. And you basically, again, you stick pods inside namespaces, and if someone has permissions to that namespace, they don't have permissions to anything else. So Kubernetes doesn't really follow the concept of users. They use certificates as users. And so, but users can belong to groups, like different like groups inside of Kubernetes, but Kubernetes doesn't really maintain its own user database. It uses certificates to maintain user databases. And so those user certificates can be associated with different namespaces inside the cluster. Kubernetes really likes to federate with other systems in order to do user management. So just to kind of give you a preview on that, we're going to get into that more as we move forward into depth. The other thing to note, other than the fact that you can logically slice out your cluster into these security partitions called namespaces, is that you can label and annotate everything. So for example, when you start a Windows box inside of a Kubernetes cluster, it automatically gets a label that says it's a Windows box. If it's a Linux box, it automatically says it's a Linux box. If it's an ARM box versus an x64 box, it automatically gets a label that's an x64 box versus an ARM box. So some of the labels are done for you automatically. The others are arbitrary. So in this particular case, we could literally label these containers that are inside the pods. We could say, look, this is an app2 pod. And we can also label the containers themselves. If we had an app1 pod, let's say that this one was app1 instead of app2, this could be the app1 pod. And this could be the app3 pod. And this could be 3 different types of applications. Now note that when you decide to run multiple instances of the same pod, let's say you're running Nginx and you want 5 replicas or copies of that Nginx pod, Kubernetes will add a random like set of alphanumerics at the end to randomize it so that you can actually see it like distributed. Like in the sense of it gives each of them a unique name. It's a unique suffix. So it'll be like Nginx-80115AZ, Nginx-YY2395. It'll actually add a random alphanumeric at the end of your name to make sure that each of the pods has a unique name attached to it. Now, you can change that by using different what they call workload types, but it does that to maintain individuality of naming inside of Kubernetes. And that's part of the labeling process, which we are going to talk about. And you have a lab on labeling as well. And then there's also annotations, and there's also controllers. The controllers we talked about already are responsible for either cloud interface or just the general configuration and health of the cluster's components. Okay. Other things around a cluster is that we already determined that a cluster is a set of nodes. So it totally makes sense here, like what we're accomplishing. Clusters have to have at least one master node in a leadership position. Because just because you have 3 masters doesn't mean they're all leaders. There's only one active leader at any given time out of the sets of masters that you have inside of Kubernetes clusters. And then you have to have at least one worker node to deploy workloads. No worker node, then you don't have the ability to deploy workloads because worker nodes are where containers go to live. And so the master node, by the way, in our diagram here, the blues, the control plane determines what goes where in the data plane, which is the green. By the way, all of that's done either through directly interfacing with the API or using kubectl, which is the kubectl command, which is used to mainly manipulate your clusters. So, just to check, do we want to keep going since we're probably going to stop, or does anyone need a break? Because if anyone needs a break, we'll definitely take a break.
I'm good. This is gelling.
Okay. because I think we got another 40 minutes. And actually, what I'll do is I'll stop us at 11:25, so you can make a little transition until you can go to your meet and greet, and then we'll reconvene at like 1:45 to make sure everything's good.
Okay.
Good. All right. We'll keep going then. All right. So just as a rehash, we've already seen that master nodes manage worker nodes. We've talked about the API server already as a portion of the piece, right? That's where all of the API calls, and it manages all the other components. We've talked about the controller manager, which basically runs like the cloud controller manager and makes sure that the components are up and engaged. etcd is the database that maintains cluster state. etcd is a CNCF project. So again, unlike leadership status within a Kubernetes cluster, etcd usually has one authoritative like system that is authoritative for writes, but they are eventually connecting, like eventually consistent with each other. They're always taking in data, reconciling it, and setting state within inside of a Kubernetes cluster. So clusters can have more than one master node, but there can only be one active leader node at any given time for Kubernetes. So the kube controller manager is actually composed of a bunch of different controllers, because it controls things like service exposure, like for public IP addresses, and that includes endpoints as well. If there's authentication tokens that need to be issued or managed, the controller manager does that. It also handles replication or copies of different applications. And if you decide to add a node or whatnot, the API server interacts with the controller manager to do that. It's all in a single application. Its job is to basically monitor, watch, manage, and report and configure and control all of the various components like the kubelets and the kube proxies and all that inside all of the Kubernetes cluster. Worker nodes, as just a refresh, are where you're going to host all of your pods, which have containers in them. Clusters typically have to have one worker node to be able to deploy items. Nodes can be configured through kube admin, ADM, kube ADM, or through kubectl. Yeah. The pod, moving down from nodes, right? So we just talked about the cluster, we went nodes, now we're at the pod. The pod is the basic unit of work. When you deploy something, you're deploying a pod. Inside that pod is some containers, and inside the container is an application. But it's like a Russian doll. You're already 3 layers in by the time you deploy a pod, right? You've already got a pod with a container with an application inside of it. Pods are considered to be totally ephemeral, just like containers are ephemeral. Now, you can deploy what's called stateful sets, and those are more persistent pods in terms of naming and service discovery, but they're still super throwaway. What isn't throwaway is the volumes that, like, for example, contain database data that you would make sure are available to these pods, especially if it's running a database application, right? But pods get a unique ID. They're always scheduled together, and they run across a number of machines. And then all the containers that are inside of a pod share the same networking stack. So they're all using the same IP address and port space. Remember that containers within a pod can talk to each other through this network stack. It's basically a loopback. It's just like 127.0.0.1. And they also have access to the shared local storage to the node that's hosting the pod, meaning that if temporary write storage was available to the pod from the node that it's being hosted on, it's available to all of the containers that are in that pod. If a specific volume is attached to a container inside the pod, that container has access to the volume. It doesn't necessarily mean that all of the other containers have access to that storage. So the reason they use pods to group containers is that they assumed from the get-go that you would have an application container with either a security or operational containers attached to it, right? And it decouples, for example, web servers from databases, or web servers from app servers from databases, or web servers from app servers from databases to, like, maybe like read replicas for databases as an example. And so it keeps things really lightweight and independently scalable, which is why you do not usually stick more than one application container inside of a pod. You usually do not stick more than one application container inside of a single pod. We mentioned that labels are key pairs that are used to help you identify your pods, but also that Kubernetes puts labels on things like nodes, for example. For example, usually when we're running a cluster, if it's a mixed cluster, there actually might be nodes that are specific for machine learning because they've got their virtual machines that have GPUs attached to them. So you might not stick normal applications out on the machine learning systems because you want to reserve those for the training models that the machine learning folks are going to put out there. So just know that they're key value stores. There are some limitations, at least to what you can put in the key. I don't remember the character limits, but we'll go over them here in a little bit. Just know that you can have multiple labels on it, even a single entity. So if it's a pod or a node or whatever, you can actually have tons of labels on there. Oh, here it is. So the label syntax is that the name, like the key part of it, must be 63 characters at most, and so must the value. It's 63s, and it can be an alphanumeric, but it can't have any dots, dashes, or underscores in it, right? Sorry, it can only have dots, dashes, or underscores in it. It can't have any other special characters. So if you want to put a dot, a dash, or an underscore inside of either the key or the value, you can do that along with any other alphanumeric, but you can't stick any special characters like an asterisk, right, or / in there. Do note that when you define a key and a value, you can actually put a prefix in before the key, but it has to be a fully qualified domain. So you'll see that actually when we run commands later, you'll see the fully qualified domain name when we run commands when we get hands-on. You then can use these labels, by the way, by running the kubectl command with specific apps like label selectors. You can say, look, I want all the pods that are labeled prod. I want all the pods that are labeled dev. I want all the pods that are labeled QA. I want you to take all of those and patch them or whatever you need to do. I want you to restart them, as an example. Now, annotations, which are different than labels. Labels are actually used in the management and execution of commands. Annotations are just arbitrary metadata. Think of them as notes that you would take about objects inside of Kubernetes. Here's the weird thing, though, is that Kubernetes itself actually annotates a lot of stuff. So if you start something and it like does a restart or whatever, Kubernetes will actually like put metadata into the annotations for the object. So you can see, hey, Kubernetes had to restart this 3 times, or Kubernetes had to do this, or it's like interesting, like the amount of like annotation metadata that Kubernetes will stick inside of objects. That's super informative. So as we get to inspecting objects later on, because it works just like Docker inspect, there's a kubectl inspect, describe, right command. Just know that as we get there, you'll see lots of annotations already predefined for you inside of your different container pod derivations.
So just real quick, I'm sorry. How long does it keep that the metadata? Is there like a schedule for removing it or archiving it?
It keeps it as long as the object's there. If the object's deleted, the metadata is deleted.
Okay.
But don't get me wrong. There are log files, for example, that like keep things like, hey, I had to restart this, or pieces like that. So don't think of it as data that's like, oh wait, if I delete this object, am I going to lose the log files? In some cases, the answer is a yes. But there are actual separate like logging entities like kubectl events, kubectl logs, for example. You can actually like see data outside of the annotations themselves.
You could also have like maybe Splunk or something, a Splunk container or Splunk app on a container that captures maybe all the other container information, maybe object information.
Well, just to say this, Brad, is that that's the one problem Kubernetes doesn't solve is centralized logging. So you're absolutely right. You actually need to come up with your own solution to solve the centralized logging problem inside of Kubernetes, because Kubernetes will log individual containers, but if those containers are deleted, I think after like 2 generations of deletion, it actually deletes the local log files. So you do actually have to mechanism to centralize that if you want to keep it long term. The cluster does not keep them long term. So Splunk, Loggly, Logzio, EFK, ELK, right? All great options for setting up logging for applications. Now, just like it is with Docker, once a pod/container is destroyed, the data, that thin writable layer that only exists on the host, is destroyed. If the pod restarts and moves from one host to another host, whatever data was there is lost, right? The only way to ensure that that data is not lost is to write it to persistent storage. And that's typically referred to as a persistent volume. And in order for a persistent volume to work, you have to define a class of storage like NFS or a hard drive or NetApp as an example. You have to define a class of storage, and then what happens is you either need to statically provision the volumes that have like basically persistent volumes provisioned for containers to grab, or you can do a dynamic claim where you basically set up the storage class and say, look, if someone makes up what's called a persistent volume claim, just give them the storage they asked for. So just know that like you can do it statically or dynamically. Most people do it dynamically, especially with cloud providers in play. But you can actually use persistent volume claims, which is listed right there, to dynamically ask for the storage and the storage size when you need it. Now, yesterday, a lifetime ago, someone said, well, can you actually like just mount environment variables or whatnot, or like sensitive information has a file inside of a container? Because we were talking about volumes, and I'm like, I can see a use case where you could do that. Well, that turned out to be prescient, because secrets and config maps, which are listed here on this page, secrets and config maps are nothing more than key value documents that you can insert into a container. And that secrets obviously is for secrets or sensitive information. So you can actually literally insert into a container under like /var/secrets, for example, /database user. And then like the application on boot could read that secrets file, grab the username and password, and then boot with that username and password. No one has seen it except for the admin who stuck it into secrets. And even that could be done programmatically so that no one sees it. Config maps works exactly like secrets in the sense of is that you can insert files into a container, a pod, if you will, and things can read off of it. And this is where you can store configuration information. Config maps can actually replace whole files inside of your configuration. So if you're like, hey, I don't want to have to copy in the http.conf every single time I want to do something, you can actually create a config map of the http.conf that has all of the values that you want for your web server, and then just mount that in as a config map. When the system boots, it's actually reading the http.conf file, and it's actually a config map that has all the configuration. And it's just that simple. So just know that while there is persistent storage that just focuses on storing data, there's also configuration storage, which is what secrets and config maps are. And by the way, that data is pulled out of etcd and presented back into the container or the pod itself. Just know that secrets are not encrypted in etcd by default, but they are base 64 encoded. So you have to decode them. You can't just glance at them and get a password, right? It's a long alphanumeric. Another thing that was mentioned yesterday that we're actually just going to mention here, and we're going to dive into more intently as we approach the time, is that Kubernetes does allow you to request resources. It also allows you to set hard limits on your resources. So you can actually specify inside of a container, you can say, look, this thing is going to request half a gig of memory, and it can only cap out at a gig of memory. You can't use more than a gig of memory. You can also say, look, I'm going to give you 500 milli-CPU, which means you're going to get half a processor at boot time. And if you need more, you can go up to a full processor, which would be 1,000 milli-CPU. So if you've got an 8 CPU system, you've got 8,000 milli CPU available for all of your applications. You can set compute and memory quotas. You can set storage quotas. You can actually set object count quotas as well, but most people aren't messing with that. Questions about resource quotas, storage, annotations, or labels thus far before we dive deeper into them? Okay. Just note, as I said before, most of the time you're going to interact with Kubernetes with kubectl. You might use the dashboard like to verify and validate, but typically you're going to use kubectl to kind of mess around with your system. All of this, by the way, is going to go through the API server, and then but from there the API server is going to call the other pieces like the scheduler, controller manager, right, or SED as needed. You're going to see the dashboard in our labs today. If you have Minikube, by the way, installed, Minikube Space Dashboard will usually make it presentable. It is an add-on, so if it's not enabled, you might have to go to Minikube add-ons to enable it, but it's there. All right. So in this first section, we actually covered all of the basic components, including some concepts like namespaces, labels, and annotations, which are really just arbitrary ways of configuring and setting up and segmenting your cluster. But we talked about the core components of a cluster, right? The controller manager, the API server, the scheduler, etcd, and then the various cloud controllers that can be in play. And then we talked about kubelet and kubeproxy, which are the components that sit on the worker nodes, and that how Kubernetes-based deployment as it deploys into pods, there's at least one application container in the pod, and then there's other containers in there that probably relate to operations, security, authentication, logging, networking, that kind of thing. And that you can get about 100 pods per node before you hit the hard limit, where that's a soft limit actually inside of the Kubernetes code base. Questions about any of this?
Your chart's better than the one in the slide book.
I will be glad to send it to you when I send it out. And actually, we'll rework it to make it even cleaner as we do a review tomorrow. All right. Well, then let's talk about working with Kubernetes. Let's get into that a little bit. What are the different like commands and other things that you want to look at? Hold on. Bear with me just one second. Not caps. Oh yeah, started. Probably need you to start if I'm actually gonna run some Kubernetes commands, which hopefully I will be. So we'll get that going. Okay. So Kubernetes basically is compatible with Windows 2019 and above. And I think it's 1.19, 1.20, but whatever the latest version is, I think it's 1.22 now. 1.20 and above all work, right? Obviously it has, particularly for the Windows space, new versions of Kubernetes are very significant right now because there is a Windows track that is continuing to evolve actively with the Kubernetes code base. Minikube is considered one of like the easiest ways to kind of get that whole thing rolling. There's also MicroK8s, which I think is published by Ubuntu. Is another way. There's also Kubernetes in Docker. Kind is another way, which is an offshoot of Docker and Docker, DIND. But Kind is another way to run an installation. Minikube does the standard thing: stop, start, delete instance, get your IP address for your cluster. You also do service and dashboard. There's a bunch of things Minikube can do, but I'm not going to necessarily review that. Kubernetes itself is usually interacted with via the dashboard application, via the API proxy, or the kubectl command line. The kubectl command line is probably the most common way in which we interact with Kubernetes. kubectl functions remarkably like Docker, honestly. It follows a lot of the same commands. The only difference is it's got different sets of objects. So let's see. Let me blow this up for a second. All right. Cool. All right, so this is Minikube. It's a single node system, right? And at present, it doesn't seem like it has any pods running. But one of the things I want to point out is that concept of namespaces has you seeing different things depending on what namespace. So for example, I have access to the default namespace as this particular user, the Minikube user. Notice that there's a bunch of other namespaces here. So if I actually join a Minikube dashboard, which will actually open up the Minikube dashboard, you'll see an overwhelming amount of information for a second. But if you look on the left-hand side, you'll see the workload sets like cron jobs, daemon sets, deployments, and whatnot. And you'll also see this in the upper left-hand side, you'll see this whole thing that says namespaces. Now notice right now it's set to default because that's the default for this user, but it's also ingress, node lease, public, and system. If I go back to the command line, right, and I kill this, and I type in kubectl get pods -a, what happens is it shows me all of the pods that have containers inside of them that are running on Kubernetes, and it will show me what namespace they're in. Notice that most of these are actually in the kube system namespace. So if I just do kube system, notice it leaves in the namespace derivation off and just gives me everything that's there. Do we see the components that we expect to see? So for example, someone tell me one of the components that's core to being on a Kubernetes master. What's a component that you see that you know for certain is definitely part of the kube master?
Core DNS.
Core DNS is actually a part of it, right? It's kind of a relatively new kind of component as far as add-ons, but core DNS is typically considered standard, right? What about the rest of it? What other core master-only components, not node components, what other master-only components do you see here?
Controller.
The kube controller manager, yep, and it says kube controller manager -minikube. So that's another one. What's one of the most important ones that maintains the state of Minikube of the Kubernetes cluster?
etcd.
etcd, exactly. That's where the database is at. Good. All right, and then what is the one that's responsible for putting pods on particular nodes if there was more than one node?
Is that the kube proxy or?
Well, kube proxy is a worker node, right? But because we have the worker node and the data control plane on the same system, we actually have kube proxy running in the system. What's responsible for placing pods on particular nodes?
Scheduler.
The scheduler, exactly right. Yeah, and notice that there's a metric server there. That's an add-on that you can turn on with Minikube. So if you do Minikube add-ons lists, you can actually see all the ones that you can actually turn on. Some of these are kind of out of date. There's like Helm no longer uses Tiller, for example. But Istio is a good one. Kubernetes so you can run virtual machines. So there's other like options in here. But going back to our thing, so the scheduler is a core component, the controller is a core component, the API server is a core component, and etcd is a core component. So is now is core DNS. What's the one thing master components that is missing here because it's not running on AWS or it's not running on Azure or GCE?
That Minikube?
Well, this is Minikube. What's missing component-wise in that list? So if we it's that one. We're missing the cloud controller, right? We have a controller manager, but we don't have a cloud controller because we're not on cloud. So there's nothing here. Okay. Now, kube proxy is here because we need that, right? Notice that there's no kubelet here. I don't see a kubelet, right? There's no kubelet here because it doesn't actually need one. It's got everything under control right here. But there is Elasticsearch, which I turned on. There is Kibana, which I turned on, and there's FluentD, which I turned on, and because there's no centralized logging system, so I turned that on, right? And then I also installed the dashboard. Oh, that's right. We're not looking at all the things. Hold on. If we look, the dashboarding system is actually in its own dashboarding like set, right? It's in its own namespace. The system namespace contains all of this. And notice that there's an ingress controller that's in its own namespace. Now, kubectl can create namespaces. Let's say we wanted to make one for, let's say monitoring, right? We wanted to do another one for testing, right? If we then go back and we get the namespaces, you'll notice that now there's a monitoring and a testing namespace listed there. So everything in Kubernetes is an API. Everything in Kubernetes is an object. You can actually add more objects by doing these things called custom resource definitions. But my point to all that is that you're probably very familiar with this command already because it operates very similarly to the Docker commands. Notice here that there's Docker run, there's describe node, create objects. I can do things like, hey, can you tell me everything I need to know about the cluster? And it basically says, hey, here's the control plane, here's kubedns. If I wanted to describe a node, I would just describe the Minikube node. And by the way, it's an overwhelming amount of information, right? But it's looking at memory pressure, disk pressure, and bit pressure. And is it ready? Right? Notice that that's another function of the kubelet. Kubelet's job is to make sure that it can monitor everything and make sure everything's working. Notice all these labels. There's a Linux label there, is there not? There's an architecture label there, is there not? Right? These are labels, by the way, that are added automatically by Kubernetes. Notice that there's also some annotations. Oh, one other thing to point out. See this prefix? This prefix is a fully qualified domain name without the period on the ends, which is really fully qualified. But anyway, it's an actual domain. So this is the key. This is the value. Everything before this little / is the prefix. Notice that the prefix has to be a fully qualified domain name. I actually don't know why that is. I actually should ask, why does the prefix have to be a fully qualified domain name? I don't know. Maybe it's so it can find the label or object, but we don't use these for like API derivation. So I actually don't know. And that's probably like the 5th time I've said that this year and I still haven't found out. We'll have to add that in there. Notice that it is schedulable by negative. So unschedulable equals false, which means it is schedulable. There's no taints or tolerations or other things that we'll talk about related to scheduling. But notice that this, like describe this object, gives you a tremendous amount of information. If we were to switch this and say, you know what, Michael, earlier we were looking at all those pods. What if I want to describe a pod? Well, in this case, let's choose core DNS, right? Notice that there is a particular long name that has to be typed here. Oh, assuming that I can do it properly. 74FF5CB5 DQCQB. Oh, that's right. I'm in the wrong namespace. Notice, by the way, that because I only had permissions by default, or sorry, visibility by default into the default namespace, even though I typed the right command, because I did not specify the other namespace that core DNS is in, I couldn't actually see in, like, I couldn't like run the command against that namespace. Now, once again, I've done a describe against a pod this time, not a node. And notice that it tells me what namespace it's in. Here's its priority, like all of his, a bunch of information, a bunch, including its IP address. Is it being controlled by anything? Guess what? In this case, there's a replica set that's controlling it. What container did it use? Here's the hash. Here's the image name with the fully qualified domain name, right? Any ports? All very useful, yes. If there was a secret, by the way, which in this case, there was a core DNS token secret. There's also a config map, right? So there's a config map here. There's a secret here. So there's a bunch of stuff actually attached to this pod. And all I did was run the describe command to get it. That's it. So just know that in general with kubectl, get is your friend. kubectl create is your friend, and that's more of a declarative thing. kubectl run is if you just want to run a particular image. kubectl apply is if you want to apply YAML, like you want to apply a configuration file. Most of the time, you're going to run kubectl get and you're going to run kubectl apply. Those are the two commands that most of the time we run inside of Kubernetes. So you just want to keep that in your brain. It's kubectl get and kubectl apply. Why apply? Because that's how you're going to load your YAML files against Kubernetes. This isn't like Docker where you're going to manipulate things manually, because when you do it in a file, it's not only going to be infrastructure as code, but it's going to allow you to declare an end state, and Kubernetes is going to go chase that end state. It's going to make it happen. So most of the time you will use apply when you're manipulating Kubernetes. Describe and things like kubectl get events, for example, or kubectl logs. Logs does require a pod at least, right? Kube describe, events, and logs are going to be the ones that you use for troubleshooting. So describe is what you just saw before. Logs and events, get events actually is what the name is, right? So it's get events are going to be the ones that you mainly use for troubleshooting. By the way, just like with Docker, you can do a kubectl exec if you want to exec a process like bash inside of a pod. So it works very similar to the Docker pieces that you saw earlier. For the most part, assume that if Docker has it, then most likely Kubernetes had it. By the way, there's a copy command. So if you want to do copy as well. This also, by the way, has help. So if you want to see help, you can do that as well. The help for Kubernetes is a little bit more robust, that it'll actually give you examples about how to do things. Is that all useful?
Yep.
Good. Yeah, and there is, by the way, bash completion for, well, both for Docker and for kubectl as well. So we're going to be using kubectl a lot in the labs for the remainder of the class. By the way, a lot of people will alias k equal to kubectl. I don't have a problem with that if you want to do that. I just don't do it for teaching purposes, but when I run it on a daily basis, I set alias to k equals kubectl, so I don't have to type kubectl. When you type it a million times, it starts to go. There's also shorthand, by the way, for all the objects. For example, if I wanted to kubectl get pods, you can do the long way, but I can also just do the shorthand. So PO is short for pods. STS is short for stateful sets. How do you find all those shorthand names, by the way? If you type in kubectl API resources, you'll actually get a list of this little middle column right here where it says, like, for example, SA, SVS. You get, if you pipe that to more, for example. Oh, really? Oh, that's right. I'm on Git Bash. Sorry, Windows doesn't have more. Just know that you can actually list out all of your shorthands. So storage classes is SC, party classes. Notice that some of them actually don't have shorthands, but it does actually help. So if you ever want to do, like, figure out what the shorthands are, or you're just looking for the API names, or you're looking for whether it's namespace, API-resources is the other very useful command when you're administering a cluster. If you don't remember what the objects are, or whether it's plural or singular, that happens, right? Just know that if you need to know what all the objects are, all the API resources are, kubectl API-resources is awesome for listing everything that's inside the command structure. Okay. So we're going to talk about the other components like API proxy, deployments, hierarchy, and some other pieces. But it's 11:25, so I just want to stop there and make sure you have some, or 11:26 actually, for transition. Does anyone have any burning questions before I let you go for your meet and greet and then a little bit of lunch afterwards?
No, not really.
Okay. Good. So it's 11:26. So we're going to meet back at 1:45. That'll be an hour and 15 minutes, give or take, right from now. So I actually won't put a timer up because I'm actually going to have to reboot my system and do a few things to it. But we're going to meet back at 1:45 Eastern time. So it's about an hour and 19 minutes from now. So I'll stop recording and I'll leave the phone call up, but I guess we'll see all of you around that time.
Sounds good.
All right. See you in a bit. Good luck with everything.
Safe travels.
All right.
Yeah.